Welcome back. Today we're taking a look at effects on functions. There are 4 different effects that we're going to be looking at. There are more, but we're only looking at these 4. Vertical shifts, horizontal shifts, vertical stretches, and inverses. The first 2 go together. These are translations. The vertical stretch is more of a dilation. We're stretching it out. And inverses are kind of different from these first 3. Vertical shifts, that's the main focus of this video. We're going to be replacing f of x with f of x plus k, k being the vertical shift, whether it be positive or negative, and we'll see exactly what a positive k does and what a negative k does. Let's look at these graphs. Our original is x minus 2, all in absolute value bars. Now, if we look at the graph, we can see that the vertex is at 2, 0, and it's touching the x-axis. If we look at g of x, it's the exact same function, except we have a plus 2 on the outside. That plus 2 actually moves our graph up 2 whole units. So the vertex is still horizontally on the same number, but it's now moved up 2 units. Hence, our noted down here, we have that it moves the graph up 2 units. So if your k is positive, it moves it up vertically. So if we take a look then at our next graph, we can see that we have our basic line 3x. It has a y-intercept of 0, and our slope is up 3 over 1. Now, if we head over to our g of x graph, we can see that it's still a 3x, still the 3x. It's just now there's a minus 3 tacked on the end. That minus 3, just like it did back when we dealt with linear equations, it moves our graph down 3 spots. And in return, it actually changes our y-intercept. So it's still the exact same graph, same slope, same direction, same everything, except we've now just shifted it down 3 units. So if we have a negative k, we're going to be moving down. So in this case, we're moving down 3 units. So in general, how does adding a constant change the graph? So what we're doing is we're adding k. And today in class we talked about the general form, and we should have that. But in general, if k is positive, you move up, and if k is negative, you move down. This deals with numbers that are being added or subtracted on the outside of the equation. So if we look at this example, f of x plus 4 is our new equation. So if f of x was just x squared, which is our basic parent function of the parabola, we're just going to take that parabola and move up 4 spaces, which is the plus 4. Again, same rate of change, same direction. It's still concave down. So essentially, we're just moving it up 4 spaces. And that's what vertical shifting does. So tomorrow, we're going to look at horizontal shifts and what that does and where that actually is in the function.